So finally, I will compare all the distance, minimum distance, okay, for ASK, FSK, and then PSK, ASK, FSK, and then PSK, PSK, ASK, and then FSK. I'm going to compare D minimum. Here I got D minimum as square root of EB. Here I got D minimum as 2 times of square root of EB. Here I am getting D minimum 2 times of square root of EB. Now you can observe here, this is the highest one. This is the highest one. Okay, this is the lowest. Lowest means in terms of D minimum. This is the medium. So that means probability of error. So the one which is having lowest will have very, very high probability of error. Very high probability of error. The one which is having highest D minimum will have very, very low probability of error. Will have very, very low probability of error. Very low probability of error. The one which is having medium will have medium probability error. Medium probability of error. And also I know the bandwidth requirement. And also I know the bandwidth requirement. That also I will write here. Here I need bandwidth of at least 2 times of RB. Here in case of FSK, I need bandwidth of at least 4 times of RB. Here in case of PSK, I need bandwidth of 2 times of RB. So now, you just observe the PSK system. It needs 2 times of RB, and also it is giving very, very low probability of error. That's why mostly we will in future, mostly in the digital communication system, mostly we will concentrate on this topic because it gives very less probability of error and also with the optimum bandwidth. ASK also may be having bandwidth of 2 times of RB, but the problem here is very, very high probability of error. Bandwidth may be okay, but error is high. That's why, again, FSK, okay, bandwidth is very, very high. Maybe probability of error may be medium, but as compared to FSK, PSK is the best. Okay, it is having bandwidth is also 2 RB, 2 times of RB, and then probability of error also very, very less. Okay, here everywhere I am comparing binary system only, binary. Okay, I am having 2 symbol, binary comparison only. This is also binary frequency shift gain. This is also BPSK, binary phase shift gain. The moment I bring QPSK, the topic is different. QPSK, 8 PSK, 16 PSK. So இதுக்கு அப்புறம் பார்க்க போறது எல்லாமே வந்து PSK related தான் பார்ப்போம். So already நம்ம QPSK வந்து பார்த்துட்டோம். QPSK வந்து பார்த்துட்டோம். Once if you use QPSK, the problem, what is the advantage you are getting? Bandwidth requirement is getting reduced. That there is no change in the probability of error. In future, we will also take another modulation scheme like 16, 8 PSK and then 16 QAM. Angala enna problem irukku, enna advantage irukku. Again, what is the limitation in the once we go for higher order modulation, say from BPSK to QPSK, 8 PSK, and then 16 PSK, we will be having advantage over bandwidth or data rate. Okay, for a given bandwidth, we can transmit at more data rate, or otherwise, for a given data rate, the bandwidth requirements can be minimized. That is the major advantage of going for higher order modulation. But other side, there is some problem on the power requirement or on the probability of error. That limitation also we'll see in the next class. In the class